Have you ever considered what causes the ground beneath our feet to shake violently, often without any warning? We're talking about earthquakes here, those moments when the solid ground beneath us suddenly becomes a rolling wave. At its core, an earthquake is a sudden release of energy in the Earth's crust. This energy creates seismic waves that travel through the Earth, causing the ground to shake. Picture a stone being thrown into a pond. The ripples that radiate outwards, that's similar to how these seismic waves spread. Though we often think of earthquakes as natural disasters, it's important to remember that they are just part of the Earth's constant, dynamic process of reshaping itself. That being said, the effects can be devastating. Buildings crumble, landslides are triggered, and lives are often lost in the process. But what is it that actually triggers these powerful and often destructive forces of nature? Stay tuned as we delve deeper into the science of earthquakes. To understand earthquakes, one must first comprehend the structure of our planet. Earth, much like an onion, is made up of several layers. The outermost layer, the one we walk on, is called the crust. It's thin and brittle, much like the shell of an egg. Next is the mantle, a thick layer of hot flowing rock. This layer isn't molten, but it's not solid either. Think of it like silly putty, solid enough to hold shape, but given enough time, it flows and moves. Then we reach the core, the very center of our planet, which is divided into two parts: the outer core, which borders the mantle, and the inner core. The core is incredibly hot and under immense pressure. Now, the crust and the upper part of the mantle together form what is called the lithosphere, which is broken up into huge pieces known as tectonic plates. These plates are constantly, albeit slowly, moving. If you could speed up time, you'd see the Earth's surface writhing and shifting like the skin of a boiling pot of soup. These plates interact at places called boundaries, and there are three types of them: convergent, divergent, and transform. At convergent boundaries, plates come together. Divergent boundaries see plates moving apart, and transform boundaries have plates sliding past each other. When these plates move, they don't always do so smoothly. Sometimes they get stuck. The pressure builds up over time, and when it finally gets too much, the rock breaks or slips, releasing a huge amount of energy. This energy travels through the Earth in waves, causing the shaking we feel during an earthquake. This is the fundamental mechanism behind earthquakes. But remember, the reality is much more complex and fascinating. Different types of boundaries can produce different types of earthquakes, and other factors, like the depth of the quake, can greatly influence the destruction it may cause. It is at these boundaries, where plates meet, that most earthquakes occur. Now that we've unraveled the mystery behind these earth-shaking events, let's summarize our findings. Our journey began with defining what an earthquake actually is. It's the shaking of the Earth's surface caused by rapid release of energy in its crust. That energy release creates seismic waves which we feel as tremors. We also dove deep into the Earth's structure, which comprises of the crust, the mantle, and the core. Each layer plays a pivotal role, with the crust being the stage where the drama of earthquakes unfolds. The concept of plate tectonics was another key point. The Earth's crust is like a jigsaw puzzle, made up of several large and small pieces called tectonic plates. These plates are in constant motion, sliding past, colliding, or pulling away from each other. Lastly, we linked earthquakes to plate boundaries. Most earthquakes occur along these boundaries where tectonic plates interact, resulting in the release of stored energy. So, the next time the Earth trembles, remember it's just another example of our planet's dynamic, ever-changing nature.